Ladies and gentlemen, welcome to the angles video. So in this one we're going to revise the names of the angles, which you learnt in your earlier years, but you will have a recap. Learn how to measure angles all the way up to 360 degrees, both on the computer here and a quick one on paper. And this is to help you get comfortable with estimating the size of the angles. After watching this video, I'm hoping that you can do all of those three things. Right, to start with, let's just have a very quick recap of what the angles are called. These are acute, between 0 and 90, obtuse, between 90 and 180, reflex, between 180 and 360. Now I say in between because these signs say that. So acute angle means that it's larger than 0, which means 0 is smaller than acute. And 90 is larger than acute, so acute is smaller than 90. In other words, in between. So smaller than 90, bigger than 0. You've got these critters coming in here. So they used to call them sharp angles when you were younger, maybe, because imagine if that got you on the skin. Ouch, ouch, ouch. Right angle, exactly 90 degrees. Exactly. So there's no in between here. It's just 90 degrees. Full stop. Done. 90. Looks a bit like 3 o'clock, hey? So you've got your acute. Could look like this, could look like this, like this, like this, like this, like this, like this. Right angle, like that. Obtuse, in between 90 and 180. They look like these guys. If I put them there, they'll be in the blue section. In the blue section. So our obtuse angles, they'll look like this. Anywhere like this. Here, 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 here. Beautiful, beautiful. Our beloved straight angle, 180. Straighty 180. Straighty 180. Probably heard that 100,000 times. 180 degrees, straight angle, straighty 180. You know it. Reflex angles, they might look like these suckers. They're getting close to being a full circle, but they're not quite there. But they're bigger than half, which is the straight angle, half the way around. So a reflex angle could look like this, or this. And I hope that is a very quick recap. Acute, between 0 and 90. Right angle, exactly 90. Obtuse, between 90 and 180. Straight, 180. And reflex, between 180 and 360. And 360 is called your revolution. Revolution. And it goes all the way around, like it revolves. So yeah, we're looking at the first step here. How do I measure angles with a protractor? So I guess that's the very first thing that you probably want to know and what you're getting asked about. Now, step one, you get your angle. And you're probably going to have it looking like that on your sheet. So what you want to do is you're going to turn your piece of paper and turn your angle to have it facing straight up. That's the first step, and I'll show you why I do that in a minute. Now, you get your protractor. You line it up to have the middle bit right on the vertex, which is the corner, right on the vertex, and you're lining it up with the line, making sure that's going over the 0, which is this line here. So, are we going to count from the 180? No chance. We're going to count from the 0 and we're going to go up to where we find the line. So we're starting at 0 and we rise it up, we're having a look, and we get to 40. So this angle is around about 40. Okay, we're going to plonk that in there, 40 degrees. Okay, here we go, here's our next angle. Now think about what I asked you to do just then. We're going to make sure that our arm is facing up, but oh no, what if we do it this way? Well, I'm going to show you why we do it this way. So we got our arm pointing straight up, and our angle is coming out to the right, which is the same direction as the curve of our protractor. So make sure the curve of your protractor is coming out in the same direction as the curve in your angle. So lining it up, making sure it's spot on. Now we're going to start from 0, curve around, curve around, curve around, curve around till we get to the line, and there it is there. Oh, it's hard to read, so I'm going to have a look at the one between 120 and 140. So it is 130. Can you see? Can you see? So our obtuse angle here is 130. Now, as I said before, we're going to make sure our arm is pointing straight up, but it's coming out the same way as the protractor. And you might find an issue here. So we follow it around, starting at 0. Oh, and it's gone further than 180. Oh no! Whatever could we do? Well, I'll show you a trick. The whole circle, if there was a full circle, it would be 360 degrees all the way around. So we want to work out what the circular part is. So one strategy you can use is you work out how big the angle is there that you don't want and minus that number from 360 to get to however big that angle is. Whatever a full circle equals minus the stuff we don't want equals the stuff we do want. So our 0 starts from the other end this time, and we're going to follow it around 0, and we get to 60. So this angle part here that we don't want is 60. So let's have a look here. 360 was the whole way around. 60 is this part. So what's left must be 300 degrees. We've got some angles on the page here. Now step 1, as we mentioned earlier, we're going to make sure the first arm is pointing straight up. As you can see, we're going to get our protractor, make sure the angle goes the same way as this. Place it there to make sure we have it on the 0 and on the dot. See it there on the thing, on the 0, come around, find out where it ends. We can see it through. So we're looking at 110 here. We start at 0, comes to 110. So that is 110 degrees. Next one, we're going to make sure our first arm points straight up just to make it easier. And our angle is coming to the right I prefer to go to the right. We've lined up the line. And that, we come out and that looks like it's right on 30 degrees. So we start at 0, come out to 30. If you want, you can draw a little line to make sure it's going the same way. 30 degrees. And here's our tricky one. As you saw earlier, this isn't going to cut it, is it? This comes around further than what we can measure. So our trick is we'll go the other way and measure this section. Starting at 0, we come around. Looks like it's pointing in between the 70 and the 80 because we started from the 0 on the inside. Between the 70 and the 80, so 75. So 360 minus 75 equals 285 degrees. Next part is, how do I estimate the size of the angle? So, you can always take a wild guess. Let's get an estimated, like a clever guess, and have a strategy of how to do that. I've got my compass here, which has the degrees all the way around. I also have a clock face, which goes around as well. I am making an assumption that you can tell time, at least to o'clock. The reason I asked you in the way of you measuring to put the first arm facing straight up is to help us with our estimation. So you hopefully will find a pattern here of what it looks like on a clock and how many degrees of an angle we can see. So if we're looking at 1 o'clock, it's 30 degrees, 2 o'clock 60 degrees, 3 o'clock 90 degrees, your right angle, 4 o'clock
120, 5 o'clock 150, 6 o'clock 180,
straight angle, 7 o'clock 210, and so on and so on and so on, with 12 o'clock being your revolution all the way around. So if you're looking at your angle and you say to yourself, well, if that was a clock, what o'clock would it be? Would it be 7 o'clock? Would it be 2 o'clock? Would it be 5 o'clock? Well, let's say it would be close to 3 o'clock. So our right angle here that we can tell is 3 o'clock. Let's make an estimation for this guy. So it's face up. Our first arm is pointing straight up, like to the 12. Where do we reckon they'll be pointing? I reckon around about 1 o'clock. Just past 1 o'clock, so probably just past 30 degrees, so 35 degrees around about. Let's have a look at this one. Pointing straight up. And what do you reckon, 5 o'clock? So if it's 5 o'clock, you're expecting it to be 5 groups of 3 or 5 groups of 30 to get to 150 or so. Let's have a look. In between. So in between 120 and 150, so your estimation's pretty close. What about this guy? So pointing straight up, and our curve is coming out to the right. And it's pointing up there. That looks like about 10 o'clock, don't you think? Because 9 o'clock would be there. Well, there you go. 10 o'clock. So 10 groups of 30 is 300. So that should be a 300 degree angle. So you might have a 360 degree protractor in class that you get to use. So it'll be the same strategy. You have your first arm pointing straight up. If the angle's pointing there, if it's pointing to near 2 o'clock, it'll be 60 degrees. If you feel like it's pointing around 5 o'clock, it'll be 150. It's pointing at 9 o'clock, it'll be 270. If it looks like it's massive, like 11 o'clock, 330. So I'm going to go through the last couple and see if you can have a guess on your own. Alright, let's have a look at this one, and I'll give you 5 seconds to think where you think this is pointing, and then we'll have a look. Alright, let's make it a bit bigger and bring it in. Did you guess about 4 o'clock, about 120? Because that's my guess. Cool. Around about 110. So our 120 guess is very close, which is good. And one more to guess. This guy. So I'll give you 5 seconds to think. Where do you think it's pointing if it was the hands of a clock? All right. Well, I reckon it's about 7 o'clock. What did you think? There we go. Now remember, if I extend the arms, it doesn't change the angle. So if I just extend my arms, the angle is unaffected. For example, if I just make that longer, it doesn't change the angle. That's if I have a steady hand. Okay. I hope that helped you to estimate. Okay, here we are for the recap. On the right hand side here you can see the sizes and what the angles are called at certain sizes, which you are now an expert on. Part 2, we learned how to measure. So the first arm points straight up. Step 2, your protractor and angle should be coming out in the same direction. My preference is to come out to the right. Then step 3, follow from 0 and go to where the line is. This one is 130, which is the obtuse angle. And for estimating, at your angle, same step at the start of the measuring. So you have your first arm coming up. Step 2 is also the same, where it comes out to the right. And you follow it around and see what it would look like if it was on a clock. So you'll have to use your estimation because maybe the clock won't be there. Of course it won't be there. You have to use your mind to imagine. In this angle, it looks like it will be pointing around about the 7, so your estimation would be somewhere in the realm of 210 degrees because 7 times 30 is 210. So a bit of practice on your 3 times tables as well. Thanks so much for coming, guys, and I hope you learnt something. One more tip, you can leave this up on your interactive whiteboard just to help you as you work through. Alright, thank you so much, and I'll see you next time.